Let's go to page 358. This is lesson 8-2. The objective of this lesson is to solve problems involving inverse and joint variation. Okay, so the last lesson we talked about direct variation. So direct variation is when one variable going up, the other one will also go up. Okay, so that's what direct means they're going the same direction. Now the inverse would be inverse variation. Means when one goes up, the other one will go down. Okay, so they're going opposite direction. So that's what inverse variation means. Okay, now the joint variation, that means when that means you're going to have the whole bunch of the things going up, and it will cause this to go up like this. So it means you got multiple of them to cause something. Okay, so you're going to have multiple input, whereas direct and inverse just have one to one. So one goes up, the other one will go up. One go up, the other one will go down, and vice versa. Again, joint variation means you got multiple factors, multiple causes to have the one go up or down. Okay, so that's what that means. So other than that, the steps are all the same. Okay, so let's go with some example. So example 1, again, it's very important to read and write down exactly what it says. So example 1, it says if y, so you can write down y. So write down as you read. So y is means equal. Inversely means k over something. Again, so when you are inversely, it will go on the bottom. Okay, directly it will go, together with a k. So inversely proportional to x. So again, when you see the word inverse, it goes on the bottom, the denominator. Okay, and everything else goes on the top. Okay, so again, same situation, and y equal to 6, so that's your y1, when x equal to 5. Right, so again, that's your case 1, so that's 1. So you're looking for x when y is equal to 12. Okay. So you're going to do exactly the same as what you did before with the direct variation. So you substitute in here and look for the k. So you got 6 is equal to k over x is 5. Okay, so when you cross multiply, you multiply by common denominator. So this will cancel out. So k equal to 30. So once you find k, you want to update your equation before you do anything else. So y equal to 30 over x. So this is your updated equation. So now you can use that to solve whatever you need. So you're looking for x when y equal to 12. Okay, so you substitute. And again, to do this, first we need to, so there are a couple we can do this, but the most common way, just go and cross multiply or multiply by the common denominator. Okay, so that's we cancel out. So you got 12x equal to 30. Then after that you divide by 12. So x equal to, and if you use calculator or you just divide, normally you want to keep in the fractional form, but if it come out exactly, if it's not like the decimal going forever, then you can just go and use decimal. So 30 divided by 12 just give you 2.5. Okay. So again, all the steps are the same, right? So translate, write down equation again. Whenever you see inverse, it goes on the bottom. Okay, and then after that, you start to solve for k. You update your equation. Use the updated equation to solve. Okay. So again, so all the steps are exactly the same as a direct variation. The only difference is that the inverse, the inverse variation, the variable goes on the bottom. So whenever you see the inverse, it goes on the bottom. Okay, let's go to example 2. Okay, so it says if z, so you can write things down as you read. So z vary means equal to k times something, jointly as x and the square root of y. Okay, again, jointly means you got more than one item. That's all it means. Okay, so you can z vary jointly as x and the square root of y. Okay, again, when you see the variation, you got to write the constant. Okay, then after that, I can get your situation. So and z equal to 6 when x equal to 3 and y equal to 16. Okay, so that's your first scenario. So case 1, so that's 1. Okay, it says find z when x equal to 7 and y equal to 4. Okay, so again, all the steps are exactly the same. You substitute the log for k, so you can update your equation. So you got 6 is equal to k times 3 times square root of 16. Okay, so you can simplify this first. So you got 6 is equal to k times 3 times 4. So to solve for k, I'm going to divide both sides by 3, and I'm going to divide both sides by 4. Okay, so this will cancel out. So k equal to 1/2 or 0.5. Okay, so normally you want to use a fraction. Okay, so you can cancel, right? So this 1, 2, so cancel. So that's how I get 1/2. When you find your k, you need to update your equation right away. So you get z equal to 1/2 x square root of y. Okay, so once you update your equation, you can use the equation to solve whatever you need. So you're looking for z. Okay, so 1/2 x is 7 and y2 is square root of 4. Okay, so you can simplify that. Square root of 4 is equal to 2, and 2 and 2 cancel out, right? 2 and 1/2, this cancel out, so z equal to 7. Okay. Okay, let's go to example 3. Okay, so it says the electrical resistance, so that's R. So the resistance of a wire vary directly as its length, and inversely, so again, whenever it says inverse, it goes on the bottom. Inversely as a square root of its diameter. So again, the resistance of the wire vary directly as length, and inversely as a square root of diameter. Okay, now go and get your situation. It says 100 meters of wire, so that's length equal to 100 meters of a wire with a diameter of 6 millimeters, have a resistance of 12 ohms. So that's your first case, okay? Then you get your second case. It says 8 meters of the second, I'm going to learn things, so 8 meters of a second wire of the same material has a resistance of 15 ohms. Find the diameter of the second wire. Okay, so that's the situation you have. Okay, so you can go through the same step. So you substitute 18 for k. So you got 12 ohms, right? R1 equal to 12 equal to k times L is 100 over square root of 6. Back up. It's not square root, it's square. Sorry about that. So you have to read carefully. Okay, so it says square, not square root. Okay. So back up on that. Okay, so it'd be 6. And instead of square, I'm going to write out twice, so easier for me to move things around. Okay. So first, I'm going to multiply both sides by, I'm going to get rid of the common denominator. So multiply by 6 and 6. So that this will cancel out. Again, don't multiply out yet. Okay. Then after that, I'm going to divide by 100. Divide by 100. So this will cancel out. So k equal to and you can kind of, if it's too complicated to figure it out, just leave it. Okay, so k equal to 6 times 6 times 12 over 100. So you can leave that, that's fine. Okay, then you update your equation. So r equal to, or you can just work it out. You know, that's going to work it out. Okay, so 6 times 6 times 12 divided by 100, okay, equal to 4.32. Okay. Okay, so once you find that, let's go ahead and get the updated equation. So 4.32 L over D squared. Okay. Okay, so now we can use that to solve that. So let's go and substitute everything in here. So R is 15 equal 4.32 times 8 over D squared. Okay, so I'm going to cross multiply or multiply by common denominator either way. So that this cancels out. So I got 15D squared equal to 4.32 times 8. Then I'm going to divide by 15 on both sides. So D squared equal to 4.32 times 8 over 15. Okay, go and get your calculator. So 4.32 times 8 divided by 15. So I get 2.304. Then take the square root of that on both sides, or take the square root of that. Back up. Okay. Let's see. Double check our math. Okay. 6 times 6 times 12 equal divided by 100. Okay, 4.32 and then times by 8 divided by 15. Oh, okay. This is 80, not 80. Okay, misread. So it's 80, not 8. Okay, so let's go and do that. Okay, so this would be, so you have to be careful as you read. So easy, very easy to make mistakes. Okay, so now you take the square on both sides. So you're going to get equal to 4.8, and the label is the millimeters. They should have the same label, so be millimeters. Okay. Okay, so you can read carefully, so copy it correctly. Okay, so again, that's another place you can make careless mistakes. Okay, but the steps are the same, so you can read, get your equation, use the case 1 to find your k. Once you find your k, you substitute to update your equation, and use your updated equation to get the answer that you need. Okay.